Dear students, greetings for the day. In the previous class, we discussed how to find the resultant of two vectors using triangle law of vectors. So, generally, by adding second vector's tail to the head of the first vector and joining the first vector tail with the head of the second vector, we obtain the sum or resultant of two vectors. If we don't know the angle between the two vectors, then we use the triangle of vectors to find the resultant. If two vectors are acting at a point simultaneously, then to find the resultant, if by representing those two vectors by the two adjacent sides of a triangle taken in an order, then the resultant is represented in magnitude and direction by the closing side or third side of the triangle taken in the opposite direction. So, if two vectors or two forces acting simultaneously at a point, then the resultant is found by using the triangle law. When they are represented two sides of the triangle taken in an order, then the resultant is represented by the third side in magnitude and direction, which is taken in the opposite direction. If three forces acting at a point simultaneously, then and if they are represented by the three sides of a triangle taken in an order, then the body will be in equilibrium. This is the alternate statement for triangle of forces. Now, if we know the angle between two vectors, then to find the resultant, we use parallelogram law of vectors. Parallelogram law states that if two vectors p bar and q bar acting at point O are represented in magnitude and direction by the two adjacent sides of a parallelogram, then the resultant is represented in magnitude and direction by the diagonal of the parallelogram, both in magnitude and direction, which is passing through the same point O. So, if two vectors or two forces acting at point O simultaneously are represented in magnitude and direction by the two adjacent sides of a parallelogram taken, then the resultant is represented in magnitude and direction by the diagonal of the parallelogram passing through the same point. So here the resultant is, when we consider the first vector p bar is represented by OA bar and second vector q bar is represented by OB bar, and let the angle between the two vectors be theta. Then by constructing the parallelogram, by drawing parallel sides AC and BC and completing the parallelogram, then the resultant of p bar and q bar is represented by the diagonal r bar or OC bar, which is equal to p plus q. So OA plus AC is equal to, OA means p bar, AC means q bar. So p plus q, resultant r bar is equal to p plus q. Now, as this resultant vector OC bar or r bar is a vector, then it possesses both magnitude and direction. Now we derive the expression for magnitude and direction of this resultant vector r bar or OC bar. So if two vectors acting at point O are represented by the two sides of a parallelogram, then the resultant is represented by the diagonal in magnitude and direction of the parallelogram passing through the same point O. Let us now derive the expression for magnitude of the resultant. Let P bar represents the first vector OA bar and second vector, let it be Q bar. It is represented by OB bar, and let the angle between them is theta degrees. Now the diagonal passing through the same point O. Now constructing the parallelogram as shown in the figure. Now the resultant OC bar or R bar is a vector and it has a certain magnitude which is equal to its length OC, and the direction is always denoted by angle. So resultant direction is represented by angle alpha, which is made by OC bar with the OD bar. So here there is right angle triangle ODC. So in right angle triangle, OD, according to Pythagoras theorem, OC square, hypotenuse square, is equal to opposite side square plus adjacent side square. Therefore, OC square is equal to OD square, adjacent side square plus CD square. Since OD is equal to OA plus AD, therefore this may be written as OA plus AD whole square plus CD square. Now we consider small right angle triangle. CDA or ADC, small right angle triangle. In triangle ADC, angle D is 90 degrees. So here AC square is equal to AD square plus CD square, and cos theta is equal to AD by AC. Therefore AD is equal to AC cos theta. Similarly, sin theta is equal to opposite side CD by AC. So from this, CD is equal to AC sin theta. So we shall use these values. So in right angle triangle ADC, hypotenuse square, according to Pythagoras theorem, hypotenuse square is equal to adjacent side square AD square plus opposite side square CD square. This is according to Pythagoras theorem. And sin theta is equal to opposite side CD by AC. So this is opposite side CD and this is AC, hypotenuse. Similarly, cos theta is equal to adjacent side by hypotenuse, AC, AD by AC. From this, AD equal to AC cos theta, CD equal to AC sin theta. Now we substitute the value of AD from 3 here and the CD value from 2. So this OC means R square. ROA square. AD means AC sin AC cos theta whole square. That is AC square cos square theta plus 2AB, A plus B whole square type. Therefore 2 into OA into AD. AD value is AC cos theta plus CD square. Here already CD square. CD means AC sin theta. So by simplifying, OA square, here this may be written as AC square sin square theta. So by taking AC square as common, OA square plus 2 into OA into AC cos theta plus AC square by taking common cos square theta plus sin square theta. Or OA square plus 2 into that is 1. So now OA means here modulus of p bar square, that is p square plus 2 into modulus of p bar, that is p, simply AC means length, q cos theta plus AC means q square into, in bracket this is 1. So this can be, since according to laws of trigonometry, cos square theta plus sin square theta equal to 1. So this may be written as only AC square or q square. So here we only require the magnitude of resultant. So R bar magnitude by taking the square root p square plus q square plus 2pq cos theta. This is the expression for magnitude of the resultant. So here, when two vectors p bar and q bar are represented by the two sides of a triangle parallelogram, which are acting at an angle theta at O, then the resultant is represented by the OC bar or R bar, which has some magnitude and direction. So here magnitude is found by using Pythagoras theorem, applying Pythagoras theorem to this large right angle triangle ODC right angle triangle. So hypotenuse square OC square is equal to OD square plus adjacent side plus opposite side square CD square, or OD is equal to OA plus AD. Therefore R square is equal to, since OD is equal to this OD is equal to OA plus AD whole square plus CD square. But in this small right angle triangle ADC, AC square equal to AD square plus CD square and cos theta sin theta values by using AD is equal to AC cos theta and CD equal to AC sin theta. So by substituting those values in these parts, we rewrite the equation like this, and by taking the AC square common in these two, we write this one. So AC square is q square, this is 1, so here 1 into q square. So we want only magnitude, therefore magnitude of R bar is equal to under square root magnitude of the first vector square and magnitude of the second vector square plus 2 into magnitude of first vector, magnitude of second vector into cos theta. All these are scalar quantities. So this represents magnitude of the resultant vector. Modulus of R bar is equal to under square root p square plus q square plus 2pq cos theta. Now we derive the expression for the resultant direction, that is for alpha. When we consider this large rectangle ODC, tan theta is equal to opposite side CD by adjacent side OD. CD by OD. CD means AC sin theta by small triangle. OD is OA plus AD. That equal to AC sin theta by OA plus AC cos theta. So by substituting here, AC means Q q, magnitude is modulus of q bar, and OA means p bar, modulus of p bar, and AC is q bar. Therefore, substituting their magnitudes, q sin theta by p plus q cos theta. Now we want only angle alpha here. Tan alpha, triangle. Tan alpha is equal to q sin theta by p plus q cos theta. So direction of the resultant is given by the angle. Therefore, alpha is equal to tan inverse q sin theta by p plus q cos theta. This is the expression for direction of the resultant. Direction of the resultant. So there are special cases when we consider theta equal to 0 degrees, then how they are changes, equations, magnitude and direction. Values are how much? Theta equal to 90. Let us calculate. Special cases. First one. When theta equal to 0 degrees, then what is the magnitude of resultant? R bar equal to e square plus q square plus 2pq cos 0 degrees. Cos 0 is 1. Therefore, this is p plus q whole square. It becomes therefore R bar is equal to p plus q. Simply. And alpha is equal to tan inverse q sin 0 degrees by p plus q cos 0 degrees. That is sin 0 is 0, 0 by something is 0. Therefore, tan inverse 0 that equal to 0 degrees. So in the first case, we observe that when theta equal to 0 degrees, then resultant magnitude is equal to as cos 0 equal to 1. This is p plus q whole square, square it. So therefore, p plus q resultant magnitude is p plus q. Or when p equal to q, it is equal to p plus p or q plus q. That is double. It will 2p or 2q. And the angle, that is direction of the resultant, becomes tan inverse q sin theta by p plus q cos theta. That is q sin 0, 0. So 0 by something is 0. Therefore, tan inverse 0 is 0 resultant. Now in second case, let us take theta equal to 90. Then magnitude of the resultant is equal to p square plus q square plus 2pq cos 90. Therefore, this value is equal to cos 90 is 0. Therefore, p square plus q square resultant magnitude. And theta alpha is equal to tan inverse q sin theta. Sin 90 is 1. Therefore, q into 1, 1. That is q by cos 90, 0. 0 into q, 0, this part. Therefore, p. So, when the two vectors are perpendicular to each other, then resultant is equal to under square root p square plus q square, and the direction is tan inverse q by p. And third case, when theta is equal to 180 degrees. Then here, since cos 180 is also equal to 0 minus 1, then it becomes, since cos 180 is minus 1, this one becomes minus. So, this one is minus q or q minus p. P minus q or q minus p. And alpha is q sin theta by p plus q cos theta. Then this is 180 degrees by cos 180 degrees. This is equal to sin 180. 0 by something is 0. For tan inverse 0, that equal to 0. And other cases also there when theta is equal to 270 and again theta equal to 360 degrees. So let us first do some problems on this parallelogram law of forces. So when two forces 30 Newton and 40 Newton are acting perpendicular to each other at a point, then find the magnitude and direction of the resultant. So, yeah, expression for magnitude of the resultant is square plus 2 into 10 to 40 into cos 90 degrees. Since they are perpendicular to each other, theta is 90 here. So cos 90 is 0. Therefore, let us calculate the, that means here the figure is actually like this. And alpha is equal to tan inverse q by p, that equal to tan inverse 40 by 30, 4 by 3, that equal to 53 degrees 7 minutes 48 seconds. That is do one more problem. The resultant of two equal forces acting at right angles to each other is 1414 Newton. What is the magnitude of each force? Here two forces are equal in this case. And they are perpendicular to each other. Theta equal to 90. P is equal to Q, or let it be both be X, and theta equal to 90 degrees. Let us find the value of P or Q or X. Is 2 to 2 into P or Q. Similarly, in theta equal to 90, tan inverse Q by P, that is, as they are equal, it becomes 1, tan inverse 1. Is equal to, here resultant is 1414. So P or q is equal to 1414 by root 2 equal to 1414 by 1.414, that equal to 1000 Newton. Therefore, first force or second force, as both are equal, its value is equal to 1000 Newton. Now let us go to know about the polygon law of vectors. When there are number of vectors to add, then to find the resultant we use polygon law of vectors. So this is the extension of triangle law of vectors. So if a number of vectors there, then to find the resultant we use this polygon law of vectors. It states that if a number of vectors acting at a point are represented in magnitude and direction by the sides of a polygon taken in an order, then the resultant is represented by the closing side taken in the opposite direction. Consider here there are number of vectors acting at point O. Let this be P bar, let this be Q bar, let this be S bar, let this be T bar, let this be U bar, and this be V bar. Now to find the resultant of these 6 vectors, we use heptagon P bar, joining the Q bar tail at head of the P bar, Q bar, S bar, T bar, U bar, V bar. Now the closing side here, now by joining the tail of the first vector P bar with the head of the last vector P bar, now this is in anti-clockwise direction. So if a number of vectors acting at point O are represented by the sides of a polygon taken in an order, that is in anti-clockwise direction, then the resultant is represented by the closing side of the polygon AG. Resultant is AG bar, which is in anti-clockwise direction. So to find the resultant, so resultant is represented by the closing side of the polygon taken in the reverse order. Polygon law of forces may be stated as if a number of forces acting at point O simultaneously, and when they are represented by the sides of a polygon taken in an order in clockwise or anti-clockwise direction, then the body is in equilibrium. Then along with all these six forces, this seventh one is also adding, as it is in opposite direction to the seventh force direction. So this becomes 0 because this AG is minus of GL. So gets cancelled and becomes resultant is 0. Then the point O will be in equilibrium. Now let us close the class. Thank you. If you have any doubt, please contact my number.